Hi guys, in this video we're going to have a look at solving quadratic inequalities. I should have put inequalities there, but it doesn't matter. So we can identify an inequality because we have the inequality sign, not the normal equality, the equal sign. But essentially we're going to do exactly the same process. Now, first thing to think about is this ready to be solved? And what I mean by that is, where we have a quadratic, this power of 2, everything needs to be on one side, and the other side has to be equal to 0, which it is. So then we look at it, is it the difference 2 squares? Is it a square number? Take away a square number? No. Is there anything common to all three terms? No. So it's definitely a double bracket factorizing problem. Now what are the factors of 12 that we can make a 4 from? Well, it's got to be 6 and 2. So let's pop 6 and 2 in there. And how do we make a negative 4 using a 6 and a 2? Well, it has to be that way around. Okay, and normally from here you would say x is equal to 6 and x is equal to negative 2. Right. We call these our critical values. I'm just going to write c dot v dot. They're my critical values. What I'm going to do with those, you could call this bit a critical sketch if you want to. So I'm going to say, right, I've got a solution of -2 and I've got a solution of 6. Remember from previous topic, when you find the roots of quadratics, this is all I'm doing. It's a happy quadratic, and if you think about your sketch, make it pretty accurate, because quadratic graphs are always symmetrical, so halfway along here is going to be where the lowest point is. And you should know by now, by completing the square, if you half this value and swap the sign, i.e. you get 2, that's where the minimum point is going to be. So that's not really essential, but I'm just trying to make you aware of roughly what it looks like. Okay, so the question is, where does this function here, where is it less than 0? Well, when we put it equal to 0 and we solved quadratics, this is where the function is equal to 0. Because when you put it equal to 0, you identify the solutions, or the root values. So anything above the line where y is 0, this is where the function is greater than 0. And below this y equals 0 line, this is where the function would be less than 0. So I'm just going to grab a different color pen quick. So where is this line, this function of x, this instruction here, where is it below the line of f of x equals 0? Well, it's all of this bit here. So some people like to get a highlighter out here and do that. And so you can see it's below the line when x is less than 6 and when x is greater than -2. What you might be asked to do is introduce or write your answer with set notation. So we just say x is such that, there's the rules, and you put a nice curly bracket around it. Now you'll notice on this part, exactly the same question, but the sign's a different direction. So we're going to have the same sketch. Everything's going to be the same. So I'll just quickly mark those on. There we go. And where is this line now more than 0? Well, it's above the line there. And at this part of the graph is also above this horizontal line. Remember, this is where the function of x is greater than 0. So we say, well, x is greater than, let's put the numbers on, it's greater than 6. And when x is less than -2. So how do we do this with set notation? Well, you could say x is such that x is always less than -2, and x is such that x is always greater than 6. But because it can be here or here, we unionize those two together with our union symbol from our sets. Okay, let's have a look at a slightly different one. So I'm going to use this example here. So we're going to look at solving two quadratics at the same time. And they could ask you two quadratics or a quadratic and a linear. We've already got the answer for this one. So let's solve this. So critical values. Factors of 4 that make 5. Well, -5, so it has to be -4 and -1. Just double check. Remember, to make a positive, these signs have to be the same, which they are. So my critical values are x is 4 and x equals 1, and we make a sketch of those critical values. Okay, so we've got 1 and we've got 4. Is it a happy quadratic? Yes, it is. So let's draw that in. And we're after where this function is greater than 0. And that is above, just always remember, this is where the function of x is equal to 0. This is where the function of x is greater than 0. So I'm going to get my beautiful pink pen out and highlight those. So we have x is greater than 4. We can pop that in our set notation. And we have when x is less than 1. We can pop that in our set notation. And we can unionize those. So where does it work for both? Now, my advice to you is always to draw a number line here. So you can see we've got the numbers -2 from up here. And we've got a 6. Let's put that there. We've got a 1. And we've got a 4. So this isn't accurate. This is just going to help me understand. So let's pop this one on first. So you've got -2 to 6. There we go. And we've got x is less than 1. So all of those. And x is greater than 4. So where does it work for this one and this one? Which values of x work for both? Well, you can see we have this section here. And we have this section here. So we've got a compound inequality here, so it's less than 1, greater than -2. So all of these values here in between 1 and -2 are in both inequalities. Let's set notation. And we've got the same thing here. So all these values, well, between 4 and 6, not inclusive. So not inclusive. That works for this inequality and this inequality. And we can unionize those together. So most of the time the question is and, but sometimes it is an or. If it is an or, basically it's where does it work for that one, or, well, that one, the top one, or that one, but that's everywhere. So they're not going to ask you that, but just in case they ever did, we would just say x is a member, so x is a member of, real numbers, or you could say, you can do this, like a z, that stands for all integers, depending on what the question is. Okay, so I hope that makes sense, and I'll do something slightly more difficult in the next video.